Hi, it's Mrs. T. Just wanted to talk to you a little bit about Chapter 2, Atoms, Molecules, and Ions, and three important laws that we're going to talk about, or we're going to kind of gloss over. Chapter 2 is another chapter that you should read and understand on your own. I will tell you if there's anything in Chapter 2 that you do not need to know, but for the most part, Chapter 1 and Chapter 2 will be done on your own so that we have the time to focus on Chapter 3, which is more important. Chapter 3 is also more difficult for you to get on your own, whereas Chapter 1 and 2 are largely review from Regents Chemistry. So these things that we're going to talk about would be the law of conservation of mass, which says that mass is neither created or destroyed. You don't need to know the name, but it was Lavoisier. Law of definite proportion, which again, you don't need to know the name, but Proust was the one who kind of is credited with this. Any given compound always contains exactly the same proportion of elements by mass. So this would mean that every compound has a constant percent by mass, which will help us in the next chapter because we will be doing certain things where you analyze percent by mass to figure out what compound was present. Law of multiple proportions. Dalton, again, you don't need to know who it was, but when two elements form a series of compounds, the ratio of the masses of the second element that combine with 1 gram of the first element can always be reduced to small whole numbers. And this just tells us that, again, different compounds have different proportions. They're going to have different subscripts. We also know that the atom contains electrons outside the nucleus that are negatively charged, protons in the nucleus that are positively charged, equal to the magnitude of the electron's negative charge, and neutrons found inside the nucleus. They have no charge, but they have about the same or just about exactly the same mass as a proton. Remember that these electrons are found in areas of high probability called orbitals. And remember that the number of protons gives us the nuclear charge, and the nuclear charge, the charge on the nucleus is always positive. The number of protons combined with the number of electrons balance each other out, and that gives us our overall neutral atom. We also know that the nucleus is very small compared with the overall size of the atom, and it's extremely dense. It has almost all of the atom's mass. Now, when we're looking at an atom and we're looking at the nucleus, if the nucleus and the atom are compared, you can see just how much empty space this atom has. Everything that's outside this nucleus, all of this space around here, is the empty space that Rutherford discovered when he said that the atom was mostly made of empty space with a positive dense nucleus. We know that isotopes of atoms have the same number of protons but different numbers of neutrons. So for example, if we're talking about carbon 12 and carbon 14, we know that carbon always has the atomic number of 6. You can look on the periodic table. We also know that the atomic number is what defines a specific atom, and so that never changes. But we also know that if we do mass number minus atomic number, we can get the number of neutrons. And so when we do this, we see that carbon 12 has 6 protons and 6 neutrons, whereas carbon 14 has 6 protons and 8 neutrons. These are going to have identical chemical properties. We usually have a mixture of isotopes, but again, they're going to have different masses based on this different number of neutrons. If we're looking at the periodic table, if you look at the one behind me, we know that the groups, let me see where I can get to a better spot here. We know that the groups or the families are the vertical columns. Those numbers of the same group usually almost always have the same number of valence electrons, and so they have similar chemical properties. But the periods are the horizontal rows. They don't show anything in common except that they have the same number of shells of electrons, and they don't actually have any similar chemical properties. When we're looking at the periodic table again, make it a little bit of a better color here. When we're looking at the periodic table again, here we have a group, here we have a period, and members of the same group have similar chemical properties based on the same number of valence electrons. So for example, group 2, the alkaline earth metal, they all have 2 valence electrons, so 2 electrons in the valence shell. They're all very similar to each other. The halogens, group 17, they all have 7 valence electrons, and that makes them react similarly, and it causes them to have similar chemical and physical properties. Again, groups or families tend to have similar charges formed when making ions. Group 1 loses 1 electron, that's a +1. Group 2 loses 2 electrons, that's a +2. Group 7 or 17 gains an electron, that's a -1. And noble gases tend not to react at all based on their stability, so they do not tend to make ions at all. So again, as I said, for chapter 2, I'm not really going to cover that much more. This was it for chapter 2. So please make sure that you read chapter 2 and make sure that you are familiar with everything in there, because since it is mostly review, it is something that we can, that I can assign to you to read. If you have any questions for me, reach out in class, by school email, or by Remind. Thanks, guys. See you soon.